So next up is the output board. It's autofocus. Anyway, you can see we have with the driver chip here, which it talks about in the article why we use that, and a row of LEDs. Again, I got a nice little board made from Osh Park to make this a lot nicer rather than the sort of hand-wired prototype. There we go, that I did before. So let's go over to the bench and build it. All right. So, like before, we have a nice little pretty purple board from Osh Park. And this board is a little different. We have inputs here. We have a buffer chip, which I said I talk about in the article on digital tools. This drives a bank of LEDs, 8 of them, through a resistor. So let's get building. I just want to check on that. As before, I'm going to start with the resistors because they're close to the board and get those out of the way first. Got my handy little resistor component bender tool here. I would consider this invaluable after doing without one for years. And then when I got my 3D printer, it's one of the first things I found and print it. It's amazing. Makes things so nice and neat. So we'll start adding the resistors in. Remember, resistors aren't polarized, so it doesn't matter which way you put them in. But, you know, it kind of looks off if you put them in opposite ways. So I like to put them all in sort of the same way. So you have the tolerance stripe, in this case gold stripe, at the same end. It just looks a little neater, and that's sort of one of my pet peeves is messy circuitry. So I like this. I'm totally with Steve Jobs, who, unlike Steve Wozniak didn't really care what the Apple II board looked like as long as it worked the way he wanted it to. Jobs, however, had him lay it out again and again until it looked nice. Like all the traces on one side going one direction, all the traces on the other side going perpendicular direction, so that the board had some aesthetic quality to it. That's one reason Apple's devices all look so nice. Is Steve Jobs' aesthetic sense and his hiring and leaning upon other people like John Ive, who shared that sense of aesthetics and that attention to detail. All right. So last resistor, one for each LED. Again, these are current limiting resistors. Yep, they all look good. They're all the right way around. Now I'll hold them in while I go through and bend the leads back so they'll stay in place when I solder. All right, there we go. Good. So we'll do that. And now you have to go through, solder each one in. I'm going to go through along here, which will give those joints a time to solidify well before I do the other side, so they're not jostling around. There we go, and we go through, clean up the wires. Oh. Bump. There we go. There we go. Now, next step I would say would be to put the LEDs on. So I use green LEDs for this one. Now notice on the board I have the LED placement pattern, so it's got the flat edge. If we look at the LED, we have a flat edge, and typically that's the cathode side, so the long lead, which is typically the anode, is the other way. So we can just go through, put them on. There we go. Now we're going to have to go through and bend the leads back on these too so that they'll stay in place. Oh, yeah. Make sure you have all the same LED so that everything's nice and balanced. There we go. So, as before, I'm just going to flip this over, holding it awkwardly so you can see, and bend the leads from the LEDs back so that they'll all stay in place when we solder. Now you don't want to bend them too much because then it becomes a little more awkward to clip them off. Okay, I grab our solder. So yeah, let's just go through, tack that one side down. Notice I'm just doing one side because these aren't perfectly snug to the board. So what I'm going to do once I get all of these tacked is go through, just push them up to the end, snug them up against the board while I melt the solder. You see they're moving a fair bit. So they weren't falling through because I bent the leads, but they weren't held snug against the board either. So this lets us, by just doing one side, easily tweak them so they're nicely in place. And now if we look around, we can see they're all snug up against the board, which is what we want, all the same height. Everything's nice and uniform. And again, nice and neat. It doesn't really make a difference functionally in this case, but you know, it's nice to have your circuits looking nice, especially if you go to the bother of laying out a board and getting boards made. If you're hand wiring, well, it's going to look messy to some extent. You can't get away from that. But if you're getting a board made, you should take the extra effort and make sure everything's nice and neat. Let's get that off there. Again, I'm keeping the leads that I clip off from flying all over. There, nice. So now we have the resistors and the LEDs. Next step would be this socket, which I have here. Again, look at the notch and the placement outline on the board. Look at the notch on the socket. Drop it in. Like I said last time, this is a very loose fit, so I bend over these opposite cornered pins, which will hold it in place while I solder it on. And then it is just a matter of soldering it on. We get nice solder joints. Now I commented last time that sockets are nice because it avoids any heat damage to the IC. Now ICs can be soldered. Obviously, you get surface mount chips that are soldered onto the board and whatnot, but that is very precisely controlled conditions, and the heat's applied for a very precise amount of time, precise temperature. When you're hand soldering, you don't have that precision. You're holding it on until it melts the solder and wicks through. So there's not as much control over the temperature, or especially the period of time that the heat's applied. So you can damage some chips if you're not very, very careful about it and if they're a little sensitive. Best to avoid that, so using sockets is a nice idea in that case. So again, we have a header, which, there we go. It's awkward and you can't see the holes you're putting it in because I'm looking at the bottom of the board, of course. So as before, I'm just going to tack that on one pin, right? And then heat that up and make sure it's sitting, there we go, flush on the board, straight, and good. Once that solidifies, then we can flip it over again, go through and solder the other pins. That looks pretty good. Now we have the same situation with this as we did with the other board in terms of power. And again, in the final version of the board, this isn't a problem because I put this kind of header connector on there, so you use any kind of headers or any kind of jumpers to do that. So this is always the VCC pin of the chip, and we can watch the trace, so that's VCC. And this time around, I'm going to be a little smarter about this. I'm actually going to pre-solder this, pre-tin it, load it up, and then I can do that. Nope. Yeah. Okay, there we go. It's a bigger pad, so it's going to hold the heat longer. And I'm going to do this. I'm going to put that down in the hole the same way. And again, just hold that while it cools and solidifies. Right. So now again, we have these loose wires. I'm going to put heat shrink on here. And my goal here, actually, I'm going to do this end first to make sure that it's all lined up. So I want this over here. I want to get these things lined up so they're even. Right. Then my little torch lighter. It's great for this. Also great for burning your fingers if you're not careful. There we go. So now this is lined up well. It's flat. We have the wire colors, it's nice and flat so we can tell which side it is. And now we just want to put that about there just to hold them together so they don't go all over the place. There we go. Done. I'm just going to carry right on through here. Not going to test it before I test it on camera. Boom. Let's see, where is, there it is. So power, here's what we're going to do. Let me grab a cable. There it is. So here we go. No. Okay, well, we'll do this. We got a couple 8-pin female to male, so I'm going to put those on here. Right? And those are going to run into that. I'm going to take this other one. Oh, look at that. We need to put this chip on. That way goes that way. So likewise, let's put it this way. So we want the blue, it doesn't matter, different colors. Do that. Let's put this here. Right, so we're using the breadboard to join them. Let's see, how does that look? That looks pretty good. Shift over a bit, yeah. So again, I'm gonna put these all to ground. Let's turn this on, and this we need to hook to power. So and let's see, we do that. Oop. What's going on? There we go. Okay. The two sections of power rail on these breadboards don't go all the way through, and there wasn't a jumper. So again, turn them all off. Let's put the first one on. Boom. And let's put it alternating pattern. You can see, as before, as I'm making these switching these input states, this doesn't update because of the latch we have there. Now when I click to do the latch, we get that, right? So I can do different patterns here. And we'll see the output change. So we do them all to one, right? Yep. Yeah, we got some wiring issues going on here. Yep. There we go. Yeah, because forgot to move the rubber shield up, so that was shorting on the bottom. So there we go. We have input and we have output. So with that, we can provide logic levels to our circuit, and we can look at the logic levels coming out of our circuit.